I quite enjoy teabagging a nice mug, so when I saw that Colin Furze had uploaded a video building a tea machine, my interest was piqued immediately.
There are many ways to make a cup of tea, but is there a very consistent way of making a cup of tea?
When I saw how he made his tea,
first off, milk will be deposited in a certain quantity, then it will then move along the line and get to the sugar. In goes the sugar, then of course along to the wonderful tea bag. In it will go, and then of course last of all, blop 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 blop.
I was shocked to the core. At best he was making some warm sugary milk.
Infusing with the flavour. This is the wrong order.
I arrogantly thought, how hard could it be to make a tea machine? Surely I could do it, and show Colin how to make proper tea. No, not property, proper tea. In my opinion, the proper way to make tea is to start with some hot water in a tea bag, let that brew for about 2 minutes, then add sugar if you're having any, and finally milk, if that's what tickles your pickle. I took inspiration from a 7-Eleven style coffee machine. You put your cup down and it adds everything in while the cup remains in the same position. First I decided to tackle the hot water. I found this instant hot water kettle on Gumtree for around $10. You press a button, wait a few seconds, and it dispenses boiling water into your cup. Easy peasy, that's the water sorted. Now to deal with dispensing tea bags into the mug. I 3D printed this contraption. It works kind of like a turnstile. It's got slots to hold 4 tea bags on a rotating semicircle. The rotation is provided through a hobby servo, so I can somewhat accurately control the angles at which the contraption rotates. I got this wooden box from Kmart for $5. The machine's brains can go inside, while the top can mount the dispensers for a somewhat clean execution. I'm mounting the tea bag dispenser here with some hot glue. An Arduino is controlling everything. You can see how the tea bag dispenser works now. It really drops it like it's hot. I don't have a sugar daddy, so I had to 3D print this sugar dispensing contraption instead. It uses an auger mechanism inspired by the Archimedes screw, a machine commonly thought of to have been invented by the aforementioned. It was originally used to pump water up heights. In this case, I will be using it to move sugar in a controlled fashion. Using the spinning screw mechanism, it scoops controlled amounts of material as it rotates. I'm using a NEMA 17 stepper motor so I can accurately control how much the screw is turned and resultingly how much diabetes is dispensed. I only used 2 of the 4 screws because I don't have any more that are long enough. I need something to hold the sugar, so I'm cutting up this water bottle to use it as a hopper. I'm using hot glue to attach it to the printed parts. Looks like the motor doesn't have enough torque for the screw to turn reliably. Originally I was using an Allegro A4988 driver to control the motor, while running it on 12 volts. I changed out the driver for a stepper driver I had from an old CNC router which can handle more current. I also changed the power supply to a 20 volt unit from a laptop. Hopefully the extra power will give the motor the assistance it needs. Oh, what? It still doesn't work. Oh shit, I was just running it backwards and clogging it up. Okay, I switched the motor wires so it turns in the correct direction. Let's load it up and try. Perfect. I wrote some code that will turn the screw exactly 5 revolutions. I'm using these scales to weigh how much sugar is dispensed in that time. By dividing that by 5, we can find an approximate of how much sugar is dispensed per revolution. We get approximately 1.2 grams of sugar per turn. A teaspoon is 4 grams, so for 2 teaspoons the motor needs to turn about 6.7 revolutions. Our old friend is back. I enjoy living dangerously, so I'm using hot glue again to mount the sugar dispenser. Okay, with the sugar sorted, it's time to get lactating. To dispense milk in a controlled manner, I'm using this Peristaltic Pump I made for a previous project where it was used to measure and pump perfume. I 3D printed some parts and used cheap skateboard bearings as the rollers. The rollers are turned by another stepper motor, again giving me precise control on how much liquid is dispensed. Peristaltic pumps work by using rollers to squish the silicone tubing whilst they rotate, creating a pressure differential which draws liquid through the tubing. Think of it like squeezing the last bit of toothpaste out of the tube, over and over again. These kind of pumps have the advantage that the liquid never has to touch any mechanical components. It remains in the silicone tubing throughout the process. Additionally, they can dispense accurately measured quantities. Resultingly, these pumps are commonly used in medical and chemical applications where sterility and accuracy are required. Here you can see it working with water. Now to figure out how much liquid is dispensed by the pump per revolution, I'm going to measure how much water it pumps into this medicine cup in 20 revolutions. We've got about 25 milliliters, so that's about 1.25 milliliters per revolution. If we want a 30 milliliter shot of milk in our tea, that's 24 revolutions of the pump. Ah, it's box mating season. We've got all the components to a good cup of tea sorted. Now it's time to put things together. Okay, I'm wiring everything up. I added a second stepper motor driver for the milk pump, as well as a 7805 voltage regulator to power the 5 volt components from the motor's power supply. An Arduino clone is controlling everything. I've not added a button right now, so I'm using the one built into the Arduino board. Just using jumpers and a breadboard for now as well, in case I need to change things. I'm using even more hot glue to secure the milk pump. I hope all this reckless, irresponsible use of hot glue doesn't come to burn me. Now I gotta figure out how to get our ingredients into the mug. Some sort of slide is what I have in mind. What's food safe but also slippery and smooth? Oh, I know. I'm gonna cut up this can and use the two halves as slides for the sugar and tea bags. I bent them a bit and hot glued them in place. I stretched the silicone tubing over this metal straw and zip tied it securely. The straw will be my nozzle to get milk into the mug. I'm gluing it onto the slide for mounting. Metal straws are great. If you don't already use them, you should give them some consideration. You can look cool as a cucumber drinking from a straw, without the impact on the environment from disposable straws. Hot diggity, it's time to turn up the machine. I primed the milk pump by running it until milk was at the tip of the straw, ready to drip. Ah, shit. The sugar dispenser's clogged up again. I tried a few more times, but it kept getting clogged. As cool as the auger drive is, I think I'll have to go with a different way of dispensing sugar. The sugar dispenser had other ideas though. In the end, my brute strength won out though. Mwahahaha. I decided Colin's approach to the sugar might be best. So I went to Kmart and got one of those portion sugar dispensers. Every time you tip it upside down, it dispenses a teaspoon of sugar. I 3D printed this adapter so it can mount onto a servo that will tip it into the tea for me. I glued the bottle in place. Time to attach the new sugar dispenser. I'm starting to lose my patience at this point, so I used the random Christmas stamp I had as a spacer to get it at the right height. Supported by such a tramp stamp, you might call this a sugar daddy after all. Testing it out, I had some issues with the servo. I figured out the 5 volt regulator could not provide enough power with this new beefy servo, so I powered it off the 5 volt rail from a computer power supply instead. The milk pump came unglued. At this point, I thought I had just glued it poorly earlier, so I glued it back on. I forgot to record that part. Okay, it's time for test 2. Ah, shit. The motor got unglued again. The stepper motor has really gotten hot from the stepper driver holding it until it's time to be used. I can't be bothered rewiring the driver so I can use the enable pin to prevent this from the Arduino, so I glued it on one more time hoping for the best. This time the servo got unglued as well. At least it works if I hold things in place. I really should not have trusted this devious hot glue. The heat from the motors is causing the glue to become soft and then let go. I installed a small cooling fan on the stepper motor and servo. This should keep them cool. You can't see it here, but it's behind the tea bag dispenser. Alright. Third time's the tea is what they say, right? Hey, it works. Blech. I have to say, my machine kind of sucks. It makes a mess, the tea is pretty bad even if it's made in the correct order, and it's a lot of hassle. Honestly, I'll just keep making it by hand. Props to Colin though for his efforts in making his tea machine. It really does work quite well, even if his tea is questionable. Thanks for watching. If you enjoyed this video, smash that like button and subscribe. I'll probably upload some more videos making stuff like this. Hopefully functional next time.